Welcome to MRL. In this learning session, we'll be learning about solid figures and solid mensuration. Now, what are solid figures? Three-dimensional geometrical figures that occupy space are called as solid figures. The solid figures have faces or surfaces, they have volume and capacity. In the solid mensuration, we will be discussing the measurements of the volume, capacity, area and dimensions of solid figures. Now, what is volume? The space occupied by a solid figure is known as its volume. The capacity is the material which a solid figure can hold is known as its capacity. The unit of volume and capacity are, the units of volume are centimeter cube and meter cube. The unit of capacity is milliliters and liters. Please remember that. Whereas you know that the standard units of volume is meter cube and capacity is liters. Now this is the chart of units of volume. Now we know 1 centimeter cube. That means if you take a cube of dimensions each of 1 centimeter, length, breadth and height is 1 centimeter. So therefore the volume of 1 centimeter cube is 1 centimeter cube. If it is a 10 centimeter dimension cube, then the volume is 1 decimeter cube. If it is a 100 centimeter dimension cube, then the volume is 1 meter cube. So please remember that. Therefore, when we talk about 1 centimeter cube, it is the volume of a cube of 1 centimeter dimension. Now the units of capacity, if you take a 1 centimeter cube, then its capacity is 1 milliliter. If you take a 1 decimeter cube, it is capacity is 1000 milliliters or 1 liter. And if you take a 1 meter cube, then its capacity is 1000 liters or 1 kiloliter. Therefore, I have written here capacity of 1 centimeter cube is 1 milliliter, capacity of 1000 centimeter cube is 1 liter, and capacity of 1 meter cube is 1000 liters or 1 kiloliter. Please remember that. Now the important solid figures which we will be discussing are the cuboid, cube, cylinder, hollow cylinder, cone, sphere, hemisphere, prism, pyramid and frustum. So we will be learning these solid figures one by one. And now let us learn the features of a cuboid, which is the first solid figure which we will be discussing. Now cuboid, as I have written here, it is a solid figure. It has 6 rectangular faces. Again I will repeat, it has 6 rectangular faces. Rather, a cuboid has got 3 pairs of congruent faces. Now let us understand what are the 6 rectangular faces. The faces are ABCD, EFGH, ADHE, BCGF, ABFE and DCGH. Let us identify them here. The rectangular faces are ABCD, then EFGH, then ADHE and CGEB or BCGE. So these are the rectangular faces, that is 6 faces. Now it has got 8 vertices. The vertices are A, B, C, D, E, F, G, H and we have got, that means total 8 vertices. Now the edges are AB is the edge, AB, then CD, then AD and BC. Similarly, we have got the edges CE, then HG, GE, HE and HD, AE and FB and GC. So in all, we have got 12 edges. You can identify them. Now every face can be a base of a cuboid. To every base, if you look at a base here, I have taken the base here as ABCD. For every base, there are 4 edges, and each edge has a vertical face, has got a vertical face, and that face is called as the lateral surface. So every base, there are 4 vertical faces, and they are called as lateral surfaces. Please remember that. Now the edge, now the question is, what is an edge? Any 2 adjacent faces of a cuboid meet in a line. If I take this surface and this surface, they meet at a line EF, and if I take this surface and this surface, they meet at a point at the line HE, and these line segments where the 2 adjacent faces meet is called as an edge, and in a cuboid there are 12 edges. Now vertex. The 3 edges of a cuboid, if you see the edge here, the 1 edge, 2nd edge, 3rd edge, they meet at a point or they start from a point, and that point is called as the vertex, and a cuboid has 8 vertices. Now if I take the length of the cuboid as L, the breadth as B and the height as H, then there are 4 lengths, 4 breadths and 4 heights. So 1 length, 2nd length, 3rd length, 4th length. Then we have 1 breadth, 2nd breadth, 3rd breadth and 4th breadth, and 1 height, 2 height, 3 height and 4 height. So in all we have got 4 lengths, 4 breadths, 4 heights. Therefore 4 in the bracket L plus B plus H gives us the total length of the edges. Very important relation for us to remember to find the total length of edges of a cuboid. Now the areas of faces. As we know that a cuboid has got 6 rectangular faces. That means 1, 2, 3, 4, 5, 6. There is 3 pairs of rectangular faces. The area of the base, that is ABCD, is length into breadth because it's a rectangle. Area of the top is again length into breadth because they are congruent faces here. And then area of the right side is breadth into height, and area of the left side is again breadth into height. Area of the front side is length into height, and area of the back side is length into height. So these are the areas how we find by knowing the length, breadth and the height of the faces of a cuboid. Now the lateral surface area. Lateral surface area is the area of the vertical faces, or we call them as the walls of the cuboid. Now to find the area, we have to add the area of the front side, the area of the back side, the area of the left side and area of the right side, and when we add, we get LH plus LH plus BH plus BH, that is 2LH plus 2BH, or 2H in the bracket L plus B, as we have listed here. Now instead of taking this, this is one important relation to find the lateral surface area, that is 2H in the bracket L plus B. Now taking the same formula here, that is 2LH plus 2BH, I can take H as common, H common, and 2L plus 2B, and you know that 2L plus 2B, that is the length, breadth and breadth is the perimeter of the base. So take the perimeter of the base here as P, then the lateral surface area is perimeter of the base into height, that is lateral surface area is equal to perimeter of the base into height. And again a very important relation for finding out the lateral surface area. Therefore lateral surface area of a cuboid can be found out by the relation 2H in the bracket L plus B, or PH. Remember that. Now the total surface area. The total surface area of a cuboid is a very simple thing. So first find out the lateral surface area, which is PH or 2H in the bracket L plus B, and then find out the top area and the base area. The base area is LB, the top area is LB. So when we add, we get 2LH plus 2BH plus 2LB, that is the total surface area. And the total surface area also can be found out by adding the lateral surface area, that is PH, and the base area and the top area is 2 times LB. So therefore total surface area is also equal to PH plus 2LB. So therefore remember, if you are given length, breadth and height, we can find out the total surface area by the relation 2 in the bracket LH plus BH plus LB, or if you are given the perimeter of the base, we can use the formula TSA is equal to PH plus 2LB to know or to find the total surface area of a cuboid. Now the lateral surface area of a cuboid is different for different bases, but the total surface area of a cuboid is the same for any base. Remember that. Now the diagonal D. The longest distance between the vertices of a cuboid is known as the diagonal. Now if I take this here, here if you see AG is the diagonal and it is noted as D, and this is the longest side of a cuboid. Now to find the diagonal D, the formula is D is equal to square root of L square plus B square plus H square, where L is the length, B is the breadth and H is the height. Therefore remember that the longest distance between the vertices, the longest distance in a cuboid is D is equal to square root of L square plus B square plus H square. A very important relation again to find the longest distance between the vertices of a cuboid. Now the volume of a cuboid is the area of the base into height. As we know, the area of base is L into B and the height is H. Therefore the volume of a cuboid is L into B into H. Remember that. Now the next solid figure is cube. Let us study about the cube, the features of the cube. Now a cube is a solid figure. It has 6 congruent square faces. Please remember this. A cube is a solid figure. It has 6 congruent square faces. It has 8 vertices. It has 12 congruent edges. Every face is a base. Here, every face is a base. To every base there are 4 vertical faces called lateral surfaces, and the total length of the edges is 12 into side, that is 12L, because L is taken as the dimension of one side. And the lateral surface area, we have to add the areas of 4 squares here. The area of 1 square is L square, therefore 4 square is 4L square. The total surface area is, we have to add the area of 6 square faces, congruent faces, and therefore it is 6L square, that is 6L square here. The diagonal D, the longest distance is the diagonal. The diagonal D is equal to L L square plus L square plus L square, that is square root of that, and square root of 3 L square is square root of 3 into L. Please remember the longest diagonal is root 3 times the dimension of the cube, that is the length of the cube. Remember that. Now the volume of cube is area of the base into height, and that is equal to L cube. Now please understand this, that cube is a special cuboid. If the edges of the cuboid are congruent, then that becomes a cube. So all the properties of cuboid and the cube are the same, except that the edges of a cube are all congruent. So please remember this. Now coming to the next important solid figure, and that is cylinder. Now what is a cylinder? It is a solid figure. It has three surfaces, that is a circular base, circular top, and the curved surface. So it has got three surfaces here, and the circular base and circular top are congruent surfaces. Now rectangle is the plane surface which generates a cylinder when rotated about one of the sides of a rectangle. This is a very important point. So if you want to generate a cylinder, take a rectangle and rotate it about one of its side. If I rotate this rectangle OCDO dash about the side OO dash, then this cylinder can be generated. So the sometimes it is asked as to what is the plane figure which generates a cylinder, and that is a rectangle. Please remember that. Now if I take the vertical height as h, and vertical height is the distance between the centers of the base and the top. The perpendicular distance between the centers of the circular base and circular top is called as the vertical height. Now area of the circular base is pi r square because it is a circle. Area of the circular top is also pi r square because both are congruent here, and the curved surface area is 2 pi r h, and the curved surface area can be found out very easily. Cut the cylinder about its height and open it, we get a rectangle. The length of the rectangle is the circumference of the circular base, and the height is h. Then the circumference of the circular base is 2 pi r, therefore the length is 2 pi r and the height is h, and therefore the curved surface area of a cylinder is 2 pi r h, and that is what I have shown here in this figure. If you see, if I cut a cylinder and open it, we get a rectangle. The length of the rectangle is the circumference of the circular base, and the breadth is the height. So if I find the area of this rectangle, I have found out the curved surface area, and the area of the rectangle is length into breadth. The length is 2 pi r, height is h, therefore the area of the curved surface area of a cylinder is 2 pi r h. Now to find the total surface area of a cylinder, very simple again. Now take the curved surface area, that is 2 pi r h, add the area of the base and the area of the height, that is pi r square plus pi r square, and that is 2 pi r h plus 2 pi r square, and that is 2 pi r plus h. So that is the formula to find out the total surface area of a cylinder. Therefore remember a few important things here. The area of the base is pi r square, the area of the top is pi r square, the curved surface area is 2 pi r h, and the total surface area is 2 pi r h plus 2 pi r square, or 2 pi r in the bracket r plus h. So these are important formulas for a solid cylinder. Please remember that. Now the volume of a cylinder is area of the base into height, because cylinder is a uniform figure. So volume is equal to area of base into height, that is area of the base is pi r square and the height is h. So please remember that volume of a cylinder is pi r square h. So now having learnt up to here, then we'll continue this in the next part of our study on solid figures. But what I suggest is, please go through these basics what we have learned. Remember the features of the solid figures we have learned, and also the different formulas, very important for calculations. Thank you.